Okay, so here we are, just gonna be talking through foundation tier paper, May 2017, paper 1, so probably one of the harder ones. Paper 2, paper 3, you can use a calculator. This one, we don't have that luxury, so let's just get stuck in, and I'll be explaining some of the questions in a couple of different ways. Just in case you don't get it one way, you might get another. But all you need to do is obviously just understand one way. That's the goal. So let's have a look at question 1. It says, how many minutes are there in 3.5 hours? So importantly here for this one, you do need to know that 1 hour is 60 minutes. Okay, so knowing that 1 hour is 60 minutes, then 3 hours will be 3 times as long. 3 hours will be 3 lots of 60, and 3 times 6 is 18. Bang on your 0, 180. So 3 hours is 180 minutes. Now half an hour, if you're going to run half an hour late, that means you'll be 30 minutes late. Half of 60 is 30. So now that you know 3 hours is 180 minutes, half an hour is 30, we can just add these two together. 180 plus 30, 0 plus 0 is 0, 8 plus 3 is 11, carry your 1, 1 plus your carried 1 is 2, 210. So you need to circle 210. First mark, we're off and running. Question 2. Work out 1/4 plus 0.5. 0.5 is half. What I'd suggest you might want to do is consider this in terms of money. So if you think of money, then just think in terms of a pound. 1/4 of a pound would be £1 divided by 4. Now 1 divided by 4 we can do like this if we're not sure. 4's into 1 doesn't go, so your remainder's 1. 4 into 10 goes 2 with 2 left over, and then 4's into 20 goes 5 exactly. And so 1/4 as a decimal would be 0.25. And 0.5 is the same as 0.50 really. Half a pound is 50p. 25p plus 50p, you're going to be left with 75p. So that one need to circle 0.75. And question 3, which of these shapes has the most sides? What I'm going to do for this one is just show you what a hexagon is. So a hexagon has 6 sides. Hexagon is spelt with an X, as is the word 6. So hex, just be thinking, what number is spelt with an X too? That's your clue. Hexagon, 6. Octagon, what animal in the ocean has got 8 legs? You're wrong if you think it's an octopus. An octopus doesn't have 8 legs, it has 8 tentacles. So just be careful with your biology. But anyway, an octagon has 8 sides. Rhombus has 4 sides. A rhombus is just a fancy name for a diamond. As well, a trapezium is also a quadrilateral that has 4 sides too. So 4 sides for trapezium, 4 for rhombus, 6 for octagon, 8 for octagon, and 6 for the hexagon. So the most sides there will be the octagon with 8 sides. So that's the one that we're going to circle. Question 4. Solve x minus 3 equals 0. So it's just a case of thinking what number, when you take away 3 from it, will give you 0. So let's have a look. If x is minus 3, is minus 3 minus 3 equal to 0? Minus 3 take away another 3, it'd be minus 6, so that doesn't work. This one, x equals 0. So does 0 take away 3 equals 0? Nope, no chance. x equals a third. Does 1/3 take away 3 equal 0? No. And finally, x equals 3. Now, does 3 take away 3 equal 0? So, if x equals 3, 3 take away 3, does that equal 0? I think it does. So, because that one works, we know that the correct answer is that x equals 3. So that's the one we need to be circling for question 4. X equals 3 solves that equation. Question 5. Work out 58 times 73. So there's a few ways of doing long multiplication. I'm just going to show you the 3 main ways which I know. So the first way is where you can partition. So we can have 58 times 73. So split the 73 into 70 and 3. Now it's just a case of working out what goes into these boxes. So first of all, top box, 50 times 70. Well, 5 times 7 is 35. We've got 2 zeros to add on, so plus 2 zeros in, 3,500. This one, 70 times 8, well 7 times 8 is 56, plus 1 zero in, 560. Thirdly, 3 times 5 is 15, add on the 0, 150. And finally, 3 times 8 is 24. Now it's a case of, in any order, adding together these numbers. So first of all, 3,500 plus 150, that's 3,650. And over here, 560 plus 24 would be 584. So the full answer will be 3,650 plus 584. I'm not a fan of this way, to be honest, because I am a lazy person and it seems to me to be an awful lot of adding up. But regardless, I've started it now, so let's carry on. 3,650 plus 584. Add them together. So, 0 plus 4 is 4. 5 plus 8 is 13. Carry 1 across. 6 plus 5 is 11. Plus a carried 1 is 12. And 3 plus a final carried 1 is 4. So we've got 4,234. Second method of doing it, which is my actual personal favourite way, is the Chinese lattice method. So doing this way, we've got two numbers times together, 58, which is 2 digits, so 2 columns of that, multiplied by 73. 73 is a 2-digit number too, so we need 2 rows. Now what we do is we split each box from corner to corner. Not very neat, but it'll do. Now what we do is we fill in over here the answers to what's above each box multiplied by what's to the side of each box. So the first one, 8 times 7 is 56. This one here, 5 times 7 is 35. This one, 8 times 3 is 24. And finally, 5 times 3 is 15. Now we add up all these numbers going sort of downwards, diagonally downwards. So the first number is 4. And we've got 6 plus 2, which is 8, plus 5, which is 13. So put the 3 there, carry 1 over. 5 plus 5 is 10, plus 1, plus that carried 1 is 12. Put the 2, carry 1 over. Then finally, 3 plus the carried 1, the final carried 1 is 4. So here we've got 4, 2, 3, 4. The final way is what I tend to call the old-fashioned way, because I was taught this way, and I'll be older than you, no doubt. So, 58 times 73, done this way. The old-fashioned column method. So what we're going to do first of all is we're going to start off with the bottom right number, I apologise, 3. We're going to multiply 3 by 8. 3 times 8 is 24. Carry the 2 across. We're now going to do 3 times 5, which is 15, plus the 2 we've carried makes it 17. So we've multiplied the 3 by all the numbers above, so now we're going to move on to the 7. New number, new line, and put a 0, because that 7 is actually 70. So that's why the 0 goes there. So first of all, we do 7 times 8, which is 56. So put the 6, carry the 5, and then 7 times 5 is 35, plus the 5 we're just going to carry makes it 40. Now we're going to add up these numbers. So 4 plus 0 is 4. 7 plus 6 is 13. Carry 1. 1 plus the carried 1 is 2. And the 4 on its own is just obviously 4. So once again, 4,234. So whichever way you do it, one of 3 ways there, you should get 4,234. Question 6, frequency tree. 500 people are asked if they drink coffee. 9 out of 10 of them say yes. So 9/10 of 500 say yes. So 9/10 of 500 is going to go here, because it's 9/10 of 500 people. First of all, 1/10 of 500 would be 500 divided by 10. 500 divided by 10 would be 50. But we want 9/10, so then we multiply that by 9. So 50 times by 9 is 450. So the number of people who answered yes, they drink coffee, is 450. So 450 people say yes, I drink coffee. Now, frequency trees, whenever the number branches off, the numbers it branches off into will always add up to the number they branched from. So these two here need to add up to 500. So the number that said no will be 500 take away 450, which will be 50. As a double check, 450 plus 50 equals 500. So you've got 2 marks in the bag now. This second set here, we need to read the next line of a question where it says 20% of the people who say yes drink at least 3 cups each day. So now that means 20% of the people who said yes, which is 450. So we need to work out 20% of 450 here. Well, 100% of any number is just the number itself. So 100% of 450 will be 450 itself. We can work out 10% of this by dividing by 10. 100 divided by 10 is 10. But if we divide this side by 10, we'll need to do the same over here too. So 450 divided by 10 is 45. Now we've worked out 10%, we can just double this to get 20%. If we double 45, we get 90. So 20% of the people that say yes is 90. And so 90 people drink at least 3 cups a day. And as I said before, each time a number branches, the 2 bits it branches off into will add up to the number they branched from. So 90 plus this one add up to 450. So to work out the number who said no, they don't drink at least 3 cups each day, we need to do 450 take away 90. So if we do this, 0 take away 0, obviously just 0. 5 take away 9 we can't do. So borrow 1 from the 4, which becomes 3. The one we borrowed goes here. So that 5 is now 15. 15 take away 9 is 6. And 3 take away nothing below it is still 3. And so then we put in 360 and we've done our frequency tree. So, looking at question 7 now. By rounding each number to the nearest 10, estimate the answer to 61 times 47, all of that divided by 102. So I'm just going to copy out the question, 61 times 47, all of that divided by 102. Okay, I'm just going to do a bit of colour coding for the heck of it. So 61, we need to round this to the nearest 10. 47, we need to round that to the nearest 10. And finally, 102, we're going to round that one to the nearest 10 as well. It sounds obvious, but it's just a case of reading the question carefully and being systematic, leaving no stone unturned really. So, 61 to the nearest 10 would go to 60. 47 to the nearest 10 would go to 50. And 102 to the nearest 10 would be 100. So now we can multiply the top. 6 times 5 is 30. We've got 2 zeros to add on, so add those on. Gives us 3,000. And the bottom becomes 100. Like so. Now, you've got 2 zeros at the bottom, 2 zeros at the top, so a bit of a shortcut way of doing this one would be to cancel the zeros at the top and the bottom. You can cancel 2, top and bottom. What we'd end up then with would be 30 over 1. Now a fraction can be read as the top number divided by the bottom. 30 divided by 1 is just 30. And so that's the question done with the working shown. 30 is your final answer. Question 8. This is about Nadia buying some stationery, pencils and rulers. So it says that she's going to buy 15 pencils. Now pencils, we're told, are 8p each. After buying the pencils, it then says she's going to buy as many rulers as possible. So she's going to buy as many rulers as possible. Rulers are 30p, which we need to know. So with her chains, after, she's going to buy more pencils. So how many pencils and rulers is she going to buy? So the pencils, first of all, we're told that she's going to buy 15 pencils. So that's going to be 15 multiplied by 8. You can multiply any way you want to, really, but I'm just going to do what I call the old-fashioned way, because this is how I was taught, and I'm obviously really old. Anyway, 8 times 5, first of all, is 40. So put the 0, carry 4 along. And then 8 times 1 is 8, plus the 4 we've carried before makes it 12. And so that gives us 120 pence, not pounds. Be expensive pencils if it's £120 for 15 pencils. So that comes to £1.20. Now bear in mind, she had £5 to begin with, and so how much money she has left would be £5 minus the £1.20 she's just spent on these pencils. 0 take away 0 is just 0. 0 take away 2, using this method, we can't do. So what I'm going to do, I'm going to borrow 1 from the 5, which then becomes a 4. And the one I'm borrowing, I'm going to move on to that 0. So this 0 is now a 10. 10 take away 2 is 8. Make sure the decimals line up. And 4 take away 1 is 3. So she has £3.80 left. Using that £3.80, she's then going to buy as many rulers as she can. Rulers are 30p, so it's how many 30p's she can get out of £3.80. And so one way of doing this would be to divide 30, or 0.30 rather, into £3.80. So doing it this way, thinking of it in terms of pence, see how many 30 pence
we can fit inside £3.80. £3.80 in pence is 380. Make sure the units are consistent. 30 into 3, we can't do that. 30 is too big. So the remainder there is all of this 3, which we're going to move on next to the 8. 30 into 38, we can fit 1, but 130 is 30, which is 8 off 38. So the remainder here is 8. And then 30 into 80, we can fit 2. 2 30s are 60, so what we've got left over, what we've got remaining, is actually 20. So 12, remainder 20. So the number of rulers she's going to buy, she can buy 12. 12 lots of 30 pence is £3.60. She's got 20p left over. So with that 20p she's got left, she's going to buy more pencils. So pencils are 8p a go. How many can she buy 8p pencils with this 20p she's got left over? And the answer is just 2. 1 pencil's 8, 2 pencils will be 16 pence, 3 pencils would be 24p, but she's only got 20p left to spend. So the total number of pencils she's going to buy would be that 15 initially, plus the 2 with the change, so she's going to get 17 pencils. And as we mentioned before, with the rulers, she can buy 12 rulers. So your final answer is she's going to buy 17 pencils and 12 rulers. Question 9. This is a classic non-calculator question. Work out 25.68 divided by 12. So I'm going to do the bus stop way. It's not the only way of excuse me, it's not the only way of dividing, but it's my favourite way, so I'll treat myself. Why not? So what you're dividing into the number goes on the outside, and the number you're dividing goes on the inside of the bus stop. So 25.68 goes on the inside, 12 goes on the outside. We're trying to fit 12s on the inside. So for this one, how many 12s can we fit inside 2? The answer is we can't fit any. 12 is far too big. And so that 2 is left over. So this 5 now becomes 25. 12s into 25, we can fit 2. 2 times 12 would be 24. So what you'd have left is 1. Now this decimal might throw some people off, but you just more or less pretend it's not there. What you do need to do though is make sure if you've got a decimal here, you line up another decimal above. So the decimal goes after the 2. But apart from that, you just carry on as normal, as though the decimal wasn't really there at all. Next of all, 12s into 16. You can only fit 1 12 into 16. 1 times 12 is obviously just 12, and 12 is 4 away from 16, so the next remainder is 4. And finally, 12s into 48. Just do the 12 times table if you want to. 12, 24, 36 would be 3 12s. Finally, 48. And so 1, 2, 3, 4. So we can fit 4 12s exactly into 48. And so because we can fit exactly 4 12s into 48 with no remainder, we can stop. So the final answer is 2.14. Question 10. Work out 3/8 times 11. So just copy down the question here. Now, what makes this strange is you've got a fraction first multiplied by a number that isn't a fraction. Fraction multiplied by another fraction, we can do that quite easily. Now you can make any number, any whole number into a fraction by writing it all over 1. Remember, you can think of a fraction as the top number divided by the bottom. So 11 is the same as 11 divided by 1, because any number divided by 1 just stays as itself. Now we can just multiply these fractions together by multiplying the tops and multiplying the bottoms. So the new top number will be 3 times 11, which is 33. The bottom number of a fraction, 8 times 1, is 8. But be careful to read the question carefully. This is only 1 mark so far. It says give your answer as a mixed number. Now a mixed number is a mixture of a whole number next to a fraction. And so we treat this in a sense as a division. To change it back to a mixed number from the top every fraction, you find how many times the bottom number fits inside the top. So how many times can we fit 8 into 33? 1 8 is 8, 2 8s are 16, 3 8s are 24, 4 8s are 32. So we can fit 4 8s inside 33. 4 8s are 32, so the remainder is how many eighths we've got left. 32 is 1 away from 33, so we've got 1 eighth left over. And so as a mixed number, as a final answer, we've got 4 and 1/8. Question number 11. We're told that a triangle has a perimeter of 32 centimetres. We're not told what sort of triangle it is though. We're not told if it's equilateral or isosceles or scalene. Scalene's where all the sides are different. But we're told here that the square has a perimeter of 40 centimetres. Perimeter is just the length of all the sides going around the outside of a shape. So 1, 2, 3, 4. A square's got 4 sides, and the special thing about a square is that each one of its 4 sides is exactly the same length. So the total of all 4 sides is 40, and there's 4 of those sides, so we can calculate how long each side is by doing 40 divided by 4, which is 10. So each side of this square is 10 centimetres. The next part of the question, it says that these two shapes are joined to make a pentagon. So you need to visualise this here. Not all the sides of this square are used to make the pentagon. This pentagon is just the bottom 3 sides. Without the top one. The top one's been taken out. The top side of the square has actually been shared with the bottom side of the triangle. So we know that this bit here, I'm going to just put it in a dotted line if you like, this bit here would also be 10 because it joins exactly the bottom side onto the top of the square. So these two have got to be equal because they join onto each other exactly. Going back to the triangle, we're told that the perimeter is 32. And so the other 2 sides of the triangle, if that bottom side's 10, then the other 2 sides, in some order, in some combination, we don't really know exactly, these 2 here must total 22. Because these 22 plus that 10 needs to give us the 32. And so we can put together these bits of the puzzle now. So the total perimeter of the pentagon perimeter, the pentagon's just any 5-sided shape. It doesn't have to be a regular pentagon. This one's just a bit of a strange looking house pentagon. So pentagon's perimeter is going to be this 10 plus that 10 plus that 10. So it's the three sides that are left of the square, 10 plus 10 plus 10, plus the top two sides of the triangle. Now, like I said before, the total perimeter of the triangle is 32. If the bottom side of it's 10, the other two sides combined at the top here must be the other 22, because 10 plus 22 gives us the full 32. So 10 plus 10 plus 10 plus 22 from the top two sides of the triangle, and 10 plus 10 plus 10 is 30. 30 plus 22 is 52. So the total perimeter of that pentagon is 52 centimetres. So question 12 about a football team. So a football team has P points. P is the number of points, W is the number of wins, and D is the number of draws. So a team has 6 wins and 2 draws. So this question is just a simple substitution into a formula. And so what it's saying here is that W equals 6 because they've won 6 times. And what we're saying about the number of draws is that D equals 2. And so this formula, P equals 3W, which means 3 times W. We've just been told that W is 6. So it's 3 times 6 plus the number of draws, which is 2. Now this is a bid mass question really, because you've got division and multiplication to do. So in the list of bid mass, multiplying comes before addition. So we need to do the multiplying step first. So the number of points is, do 3 times 6 first, which is 18. And finally we can do 18 plus 2. And 18 plus 2 is 20. So the team has 20 points. 12b. After 33 games, a different team has 53 points. 11 games were draws. How many games has this team lost? So again, we need to know that the points equals 3 times how many games are won plus the draws. This is going to be our starting point. So what are we told already? So what we're told already is that 11 games were draws. So the number of draws, we know now that that's 11. And so we can whack that into the equation. So the number of points they've got equals 3W plus 11. But again, it says here that the team has 53 points, so we can also add that one in. So if a team has 53 points, we can replace the letter P with its value. So the value of P is 53. So now we know that P, which is 53, equals 3W plus 11. So what we need to do now is to solve this equation to work out how many games were won. So there's a few ways of solving equations. What I'll do now is I'll just show you a bit of a shorthand way. So what we want the 3W on their own, and on the other side we want the numbers. So we can move this plus 11 away to the other side. And what we're going to do is swap the side and swap the sign. What's actually happening is we're going to take 11 from each side. If we take 11 from this side, it disappears, but to balance out the equation, we take 11 off here. It just looks like you're swapping the side and swapping the side. As I say, it's a bit of a shorthand way of explaining it. So 3W will equal 53 take away 11. 53 take away 11 is 42. So the 3 here with a W, the 3 is multiplying the W. We want 1W. So if that 3 is multiplying the W, the opposite of multiplying w is to be dividing. So if that 3 moves across, it'll swap to a divide. And so w will equal 42 divided by 3. So it's a case of how many 3's fit into 42. Threes into 4, we can fit 1 inside, and the remainder is 1, because 3 is 1 off 4. And finally 3's into 12 goes exactly 4 times. And so the number of games that were won, we've now figured out must be 14. So W is 14. So, going back to the start of the question, we're told that there's 33 games that have been played in total. So of the 33 games, we know that 11 were draws, and we've just figured out that another 14 were wins. So the other games which are left over must be how many games were lost. So we need to take away 11 and 14 from 33. So just looking at the 3 actually. 3 take away 1 is 2. 2 take away 4, we can't actually do that. So if we borrow 1 from the 3, it becomes a 2. The 1 we've borrowed can go next to the 3, which now becomes 13. So 13 take away 1 is 12. Take away this 4 would be 8. And 2 take away 1, take away another 1, leaves you with nothing. And so after all that, how many games has this team lost? The answer is the team must have lost 8 games. Question 13. We've been given a sum here where it says just 2 plus 0 plus 1 plus 7 equals 10. The main thing is, notice, here we've got the same digits for 3 different calculations, and we need to make each one correct only by using plus, minus, multiply, divide, and brackets if we need. So we can use any combination of these, but we can't use anything else apart from these symbols. So first of all, we need to make this equal minus 4. If we can only use plus, minus, times, and divide, what I'd suggest is we might be just wanting to use a minus somewhere, because we need to be taking away a number which is bigger than the number we start with to end up with a minus. So how can we make 4, forgetting the sign for a second, how can we make 4 from 7, 1 and 2? Well, 2 plus 0 plus 1 is 3, and 7 take away 3 would be 4. So if we flip that around, 3 minus 7 would be minus 4. And so what we could do first of all is add together the 2, the 0 and the 1, which gives us 3, and then minus 7. If you wanted to put brackets around here, you could do. You don't have to, doesn't really make a difference, but if it makes you feel more comfortable to include brackets, you could do that as well. This one here, all of this needs to equal 0. Now you could be racking your brains for a long time about this one, but what I'd suggest is to just try and remember that anything multiplied by 0 equals 0. So we've got 0 here, so if we multiply everything in a line, it's just one option of doing it, then all that would equal 0. 2 times 0 is 0. 0 times 1 is still 0. 0 times 7 still gives us 0. So remember, anything multiplied by 0 is 0. The final one, we've got 2 to the power 4. So you need to work out what 2 to the power 4 is. It means 2 times by itself 4 times. So it's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8, times 2 again is 16. And so we need to make these numbers here come to 16. So how to do that? We've got a 2. Does 2 multiplied by a number give us 16? Actually, yes, it does, doesn't it? Because 2 times 8 is 16. So what we could do is section off this 1 and 7 and make our 8 by doing 1 plus 7. And our 2, we could just keep here. 2 plus nothing is still 2. So 2 times by 8 would give us 16, which is the same as 2 to the power 4. So that's one way it could be done. Let's have a look at the next question. Question number 14. A number is picked at random from the first 4 prime numbers. So first thing to notice is it's mentioning about prime numbers. So the first 4 prime numbers. Okay. So the first 4 prime numbers, by the way, have been given some here. So always read the question carefully. The first prime number's 2. Second one's 3. The third one's 5. And the fourth one's 7. A prime number is a number that can only be divided by 2 different things. So 4 wouldn't be a prime number because 4 could be divided by 1, 2 and 4. And so we need to fill in 5 here. And the first 4 square numbers, a square number just means a whole number multiplied by itself. So the first square number is 1 times 1, which is 1, 2 times 2, which is 2, 3 times 3, which is 9, and this one here will be 4 times 4, which is 16. And so we've got the square numbers here, and down here we've got prime numbers. Now to fill in the table is the columns added to the rows. So it's just a case of adding them all up. As long as you do it carefully, you should get 4 marks comfortably here. So the first one, 2 plus 1 is 3. Second one, 2 plus 4 is 6. This one, 2 plus 9 is 11. 2 plus 16 is 18. And just keep going. 3 plus 1 is 4. 3 plus 4 is 7. That one's been done for us. 3 plus 16 is 19. And keep going. 5 plus 1 is 6. 5 plus 4 is 9. 5 plus 9, 14. And 16 plus 5, 21. Final row, 7 plus 1 is 8. 7 plus 4, 11. 9 plus 7, 16. Finally, 16 plus 7 is 23. Part B, it then says about what's the probability that the score is a prime number. So what we've done here is a probability space working out all the possible combinations of scores. And so what we're after now is working out which ones of the possible scores are themselves a prime number when they're added together. So the first prime number from the list of 16 we've created, 3 is a prime number, as is 11, 4 isn't, 7 is, 12 isn't because you can half it, 19 is a prime number, need to know that, 6 isn't because you can half it, 9 isn't, you can divide it by 3, 14 can be halved, 21 you can divide by 3 and 7, so none of that row are prime. 8 isn't prime because you can half it for one thing. 11 is a prime number though. 16 isn't. Finally, 23 is a prime number. And so from looking at the table, have a look how many of these are prime numbers. We've got 1, 2, 3, 4, 5, 6. And so 6 out of 16 are prime combinations. So 6 out of 16 are prime. Now, just looking at the language of that, 6 out of 16 are prime. That will help me put it into a fraction. Whatever comes after the of is a pretty sure guess what's going to go on the bottom of the fraction. So 6 on top, out of 16. Now it could be left like that, with probability you don't need to simplify unless the question specifically asks you to. But you know, if you want to be safe, do simplify it down if you feel comfortable. The 6 and the 16 can both be halved. So half of 6 is 3 and half of 16 is 8. So then we'd end up with 3/8. Now we've got question 15, which is a ratio question. In the school show, we're told the ratio of girls to boys is 1:1. That means the number of girls is exactly the same as the number of boys, because 1 is the same as, well, 1. Also, we're told that the number of girls that sing as a ratio of the number of girls that don't sing is 1:2. We're also told that 8 girls sing in the show. So what we're going to do, we're going to take this bit of information and see if we can get something useful out of it. So we've got singing girls on one side. We're going to compare this to the number of non-singing girls. So we're just going to compare this in a table as so. So we're told that number of girls that sing is a ratio of 1:2. So for every 1 girl that does sing, we've got 2 girls that don't. But because we're told here that we've got 8 girls that do sing, we can say that this 1 lot of singing girls is worth 8. 1 lot represents 8, and so 2 lots, or 2 groups, whichever way you want to think of it, must represent double this. 2 lots of 8 would be 16. So from this, for 2 lots of girls that don't sing, represents 16 girls, and the 1 lot that do sing, as we've been told, is 8. And so 8 plus 16 tells us that we've got a total of 24 girls. So the number of girls that we have, which is represented by that 1 in the ratio, actually represents 24. I'm just going to stop there for a second because I do know from experience that ratio is an area that people just tend to strongly dislike. Not everybody, but enough people to warrant me doing another way. We can do a build-up method. If that way didn't make sense, or if you forget that way in the exam, there is another way of doing it, which is slower, but would still work. What this means is for every 1 girl that does sing, we've got 2 girls that don't sing. So you can imagine just building it up, if you'd like. For every 1 girl that does sing, we've got 2 girls that don't. So keep building this up until we have the 8 girls that do sing, as the question tells us. Another 1 that sings, add in another 2 that don't. Another 1 that sings, another 2 that don't. Another 1 that sings, another 2 that don't. And just keep going. For every 1 singing girl, just put down 2 that don't, because that's what the ratio is literally telling us. Another 1, another 2. Oops. And finally, now we've got 8 singing girls, add another 2 that don't sing. We've got a total here of 16 non-singing girls, like we said before, and 8 that do sing. So by doing a slow build-up method, or even like a tally chart, you'd get that 8 girls do sing, 16 don't. And 8 plus 16 gives us a total of 24 girls. So 24 girls in total. The number of boys is represented by the ratio part 1. So it's a 1-to-1 ratio. So if there's 24 girls, there must also be 24 boys. Because that 1 for the boys will also represent 24. The question asks us, how many students are there in the show altogether? So the total number of students in the show altogether will be the number of girls, which is 24, added to the number of boys, which is the same as the number of girls, which again is 24. So 24 girls plus 24 boys would give us a total of 48 students in the show altogether. And that's your final answer, 48 students. Question 16. P and Q are points on the line 3x plus 2y equals 6. We're told to complete the coordinates of P and Q. Now, you might not believe me, but the examiners are being quite nice to you here, because they've told you that P is a coordinate where x is 0. So if we divide these up here, 3x plus 2y equals 6. I'm just copying down the initial equation. And for Q, again, 3x plus 2y equals 6, because that's the equation of a line at any point. I say the examiner's been nice because at P, they've said that the x coordinate at P equals 0. Remember, x comes first and then y. And so if x is 0, 3x is 0 as well, because 3 times 0 equals 0. And so we know from that that for point P, when x is 0, 3x is 0, so we can completely forget about 3x, and we're just left with 2y equals 6. So if 2y equals 6, then we can half that. Half of 2y is 1y, so half of 6 is 3. And so when P is x is 0, y is 3. So we know the coordinates of P as 0 and 3. In the same way at Q, we're told not the x coordinate but the y coordinate. We're told that at point Q, y equals 0. So if y equals 0, 2y will be 0. So we can completely ignore the 2y part of this question. And what we'll be left with is just 3x equals 6, because the 2y disappears because y is 0. Y is nothing. If 3x is equal 6, then we can work out what 1x is. To go from 3x down to 1x, we can just divide by 3. But to keep the balance of the equation, if we divide one side by 3, we'll divide the other side by 3 too. So 6 divided by 3 would leave us with 2. And so at point Q, when y is 0, x must be 2. And so we've now got 2 points done. So P is 0 and 3, and point Q is a point when x is 2 and y is 0. And we can use that for part B. Now, for part B, we're asked to plot this graph. But again, if a question is part of a previous question, so part B links to part A, don't be looking at this and getting panicked. Think about if it links to part A, in which case it does. If I just quickly nip back to part A, 3x plus 2y equals 6. It's exactly the same equation, and so the exact same principle applies. 3x plus 2y equals 6. So we've been given from part A 2 points on the line. Point P is 0, 3. So point P is this point on the line here, which I'm just going to mark in with a cross. And point Q is 2, 0. That means when x is 2, y is 0. So I'm going to go 2 along and nothing up, which will just be there. And so if I put this as a cross, then I'm almost there. Now here, you need to be confident in recognizing the equation of a straight line. A straight line will have nothing fancy in it. It won't have any x squareds, won't have any y squareds, nothing fancy, just normal x's, normal y's. So a certain number of x's, a certain number of y's equals 6. Typically the equation of a straight line equals y equals mx plus c. All that means is a certain number of y's, not squared or cubed or anything, equals a number followed by x plus c. That equation, if you wanted to, would rearrange to that. But as long as you're confident in spotting and going with your intuition that this will be a straight line, especially for a 2 marker, think about it, for 2 marks, if they're going to give you something absolutely awful, probably not. This will be a straight line. So all you need to do now, using that and trusting yourself, is to do a straight line from x between -3 and 3. Now you've got 2 points on your line already, and so as long as you're confident, just do 2 points going through both crosses that you've drawn. I'm just trying to get this right. There. And that will do. That will be the equation of your line plotted nicely like that. So as long as it just goes through 2 points and goes at least from x being -3 to x being 3, which it does, you're fine. And that's your extra 2 marks for question 16. Next question. It says here to circle the expression that does not simplify to y cubed. Now there are rules with powers. The little number tells you how many times you're multiplying the big thing by itself. So y cubed means y times y times y. So that is definitely the right one. That's more or less the definition of y cubed. Now this one over here, if there's no power next to the y, you can always safely assume it's the power 1. So that means y to the 4 divided by y to the 1. So you need to remember that when you're dividing things, you're subtracting the little numbers. So the new power of y for this one will be 4 take away the 1, which is 3. And so that one does simplify down to y cubed. That one does work. Similarly, when you're multiplying them, involving the little power numbers, when you're multiplying them, you add the little numbers together. Y squared means y times y. And you're timesing that by another y. Just a different way of seeing it, but ultimately, you're timesing y by itself 3 times. So you've got y cubed, and so that one does simplify to y cubed as well. So that one, again, simplifies down. So by process of elimination, if nothing else, it's going to be this one. Y to the power 6 divided by y to the power 2. That one would simplify down to y to the power 4. So that one doesn't simplify down to y cubed. So when it says circle the expression, be careful to do exactly what the question says and circle the one you need to. So you need to circle that one. Question 18, a standard form question. I'm going to explain how to write this big number down. You might be okay writing down big numbers, but sometimes when numbers get really big it can be a bit confusing. So first of all, let's have a look at 6 million. What you're best off doing, I think, is to write down just the number 6 first. That's 6 million, is it? No. So just keep on adding zeros until you get it right. So that's 60. Another 0, you're talking about hundreds. Another 0, you're talking about thousands. That's 6,000. Add another 0, that's tens of thousands. That's 60,000. Another one is 600,000. Then finally, after hundreds of thousands, you get millions. 1 million is a 1 with 6 zeros after it. In the same way, 6 million is a 6 with 6 zeros after it. So that is your 6 million. I'll just highlight that, so that's that part of the number done. Then it says 5,000. 5,000 is, well, you should probably know what 5,000 is. 5,000 is a 5 with 3 zeros. And then 200 is a 2 with 2 zeros. So if you think about that all being added up, 6,005,200 all combined would look like this. So start from the left and add them all up together. Nothing plus nothing plus nothing is nothing. Same here. Nothing plus nothing plus 2 is 2. 0 plus 5 is 5. 0, 0, and 6. So it's important to have that number right. But now you need to put this number in standard form. Standard form is a certain way of writing the number. What standard form means is the first part of your number needs to be between 1 and 10. So if I write out this number full, where would I put a decimal to make this number between 1 and 10? The first part of it, that's a really big number. That's thousands. That's 600. That's 60. A decimal point would have to go here. That'd be 6 point something, which is between 1 and 10. The next thing you need to think about is how many digits are between where the decimal needs to go and where the decimal actually is. With standard form, if it's a whole number, the decimal point would go at the end of a number there. Like 0.0 if you wanted. So in between where the decimal needs to go and where the decimal actually is, you need to be counting how many digits are between. The answer is you've got 1, 2, 3, 4, 5, 6 digits between. And so what this tells us is that in standard form, the power of 10 that goes next to it would be a 6. So you write out the number in full with the decimal point included, 6.005200 times 10 to the 6. Now these last zeros, the trailing zeros at the end of a decimal number, you don't need. And so what you can do is simplify it down slightly further and just put 6.0052. Forget them two numbers. Times by 10 to the power 6. And so write that on the answer line and you're good to get your marks. So 6 point, and trouble with my pointer here, 6.0052 multiplied by 10 to the power 6. And you're done.
Question 19. Use 8 kilometers equals 5 miles per hour to convert 96 kilometers to miles per hour. So we've got that 8 kilometers an hour equals 5 miles per hour. So what we need to do is one way or another build this up. So we're not wanting just 8 kilometers an hour, we're wanting 96. So one way we could do this would be to see how many times 8 goes into 96, and we can do this by dividing. So how many 8s fit into 96? First of all, how many 8s fit into 9? That's 1, with 1 left over. And finally, how many 8s fit into 16? That's 2. So that tells us that to go from 8 to 96, we'd have to multiply by 12. However, if we multiply this side by 12, to keep the balance, we need to multiply this side by 12 as well. So what we have is 8 times 12 gives us 96 kilometers per hour.
and then over here 5 times 12 gives us 60 miles per hour. So our answer is going to be 60 miles per hour. Question 19. Use x kilometers per hour equals y miles per hour. So we're told that when it's 8 kilometers per hour, that's the same as 5 miles per hour. And we want a formula for y in terms of x. So what it's saying to us here is that y is the value in miles per hour, and x is a value in kilometers per hour. And because we want a formula for y in terms of x, what that means is we want an answer in the form y equals a number, or y equals something relating to x at least. So what we can do here is a table. Now, I don't think this is a particularly easy question, but we are told that when y is 5, x is 8. And so just trying to get it in terms of 1y, we can go from 5 down to 1 by dividing by 5. But if we divide one side of a relationship by 5 to keep it in balance, we'll also have to do the same to the other side. So what we need to do here is 8 divided by 5. So 5's into 8 we can do using the good old bus stop method. So 5's into 8 we can fit 1, make sure the dot lines up top and bottom as well, and the remainder is 3. So that 0 has now become 30. Now 5's into 30, finally we have 6. And so that tells us that when y is 1, x is 1.6. And so y will equal x divided by 1.6. So why is it divided by? It's because our speed in miles per hour, which is y, is smaller than the speed in kilometers per hour. We've got it here as a ratio of 1 to 1.6. When one of the numbers is 1 and the other number isn't a 1, the conversion factor is the other number which isn't 1. So the conversion factor for this one is 1.6. So we're either going to times or divide by 1.6. So y equals x divided by 1.6. We could say y equals x divided by 1.6. Another way of saying this equivalently is that y equals 5/8 of what x is. For my money, that's quite a hard question, and I do think it's quite a tough one, especially for 2 marks, but there you go. So y equals x divided by 1.6, or y equals 5/8 x. Question 20, we're talking about a square and a circle. First of all, it says the area of a square is 64 centimeters squared. So we need to know that the area of a square, any square or rectangle, is the length multiplied by the width. But for a square, the width and the length are the same. All the sides of a square are the same length. So because the width is the same as the length, the area of the square, little square symbol, is the length times the length, which we're told is 64. We've been given that piece of information. And so L times L means L squared. So what number, when we multiply it by itself, would give us 64? You might take a bit of trial and error. Is it 6 times 6? Is it 7 times 7? Eventually, you should realise that L would have to be 8 centimetres. And so the length of this square, from end to end, is 8 centimetres. And because the circle touches the square, the length of the square is exactly the same as the diameter of the circle. But to work out the area of the circle, we're not interested in the diameter, we need to know the radius, which is from the middle to the outside. The radius is always half of the diameter, so the radius is half of 8, which is 4 centimetres. And the formula for the area of a circle is pi r squared. Pi times the radius squared. And so what we're saying here is that the area of a circle is pi times the radius squared. But we've just worked out that the radius is 4. So it's pi times 4 squared. Now it's BIDMAS. Do we multiply or do the power first? We do the power, which only relates to the 4. And so 4 squared we need to work out first, which is 16. And pi times 16 simplifies to 16 pi. Now we're not going to use pi equals 3.14 or 3.142 because you need to read the question carefully. It says give your answer in terms of pi. What that means is we're not going to use a numerical value of pi. We're going to leave a symbol for pi in the question to the end, just as we would do with like an x or a y or a z. So the final answer is the area of the circle is 16 pi. Moving on to question 21. This is a bloke buying tickets for a show. So he's buying 4 adult tickets at £15 each. And so over here we can work out the price of those. 4 adult tickets, £15 each, would be 4 times 15, which will be £60. He's also going to buy 2 child tickets, which are £10 each. So 2 times 10 is going to be £20 for the child tickets. So the total he's going to pay for the child tickets plus the adult tickets is £60 plus 20, which is 80. But now we've got 2 separate charges to consider. The first one is this booking fee at 10%, a 10% booking fee, and separate to that is a credit card fee of 3%. A common mistake for this question is to combine the 10% and 3% together in one step as 13%. But what you need to do first of all is to consider first of all separately 10% of 80. And so if we look here now, we always know that 100% of any number is just the full number itself. So 100% of £80 will just be £80. To get 10%, we can divide by 10, which is the same as moving the decimal back to the left 1 digit. But because these are whole numbers ending in zeros, it seems to be the same as just knocking off a 0 of 100 and knocking off the 0 of the 80. So knock the 0 off the 80, if you like, we'd have £8. So total, including the booking fee, is £80 plus £8, which is £88. But we're not quite done yet, because we've also got the small matter of the credit card fee. Now the credit card fee is an extra 3%. But what we're now working out here is 3% of this new subtotal of £88. So first of all, we can work out 100% of 88, which is just 88. then what we can do is work out 1%. To work out 1% of any number, we divide the number by 100. Dividing by 100 is the exact same thing as moving the decimal place back 2 digits to the left. And so 88 becomes 0.88, which in terms of money would be 88p. But we want to have 3% of 88, which is 1% plus 1% plus 1%, or in other words, is 88 multiplied by 3. So I'm just going to do it up here where there's some more space. 8 times 3 is 24, carry the 2. 8 times 3 again, 24, plus the 2 we've just carried, is 264. But remember, it wasn't 88, we were talking about 2.88. We've got two numbers after the decimal here, so we need two numbers after the decimal here as well. So 3% would be £2.64. So we've worked out the credit card fee, which in itself gets us an extra mark. Finally, what we need to do to work out the grand total charge of these tickets when paying by credit card is to work out the £88 we had here plus the final charge of £2.64. So £88 plus £2.64. 0 plus 4 is 4. 0 plus 6 is 6. Make sure the decimal lines up top and bottom. 8 plus 2 is 10. Carry the 1. Then 8 plus the 1 we just carried is 90. And so the grand total at the end of all of that would be £90.64. Quite a long, hard, long-winded question, but you would have to end up with 90.64 to get all 5 marks. Okay, question 22. We have a formula, density equals mass divided by volume, and we're talking about two different types of solid. We've got solid A on one side, on the other side we're talking about solid B. So solid A relates to solid B, but we're not told what the mass or volume of either of them are. And so for questions like this, your best bet, I think, is to make some numbers up. Make some numbers up which are nice and easy to deal with. So because A relates to B, A is dependent on B, let's make up some numbers for B. So let's say the mass of B is a nice easy number to work with. Let's say it's 10. Same with the volume. Let's say the volume, again, is something nice and easy, a nice easy number. Let's say it's 2. Just making something up, making anything up really. So you've got the mass of B, which is 10, and the volume of B, which is 2. So the density of B is its mass divided by its volume, which is 10 divided by 2, and 10 divided by 2 is 5. And so the density of B, we've just worked out, is 5, if those numbers existed. So the solid A, we're told it's 6 times the mass of solid B. So the mass of A will be 6 times the mass of B. If B was 10, 6 times 10 would be 60. And the volume of A is 3 times the volume of solid B. 3 times 2 would be 6. So in relation to solid A, we know that its mass is 60 and its volume would be 6. And so using this formula at the top, the density of solid A would be its mass, which is 60, divided by 6. How many 6's make 60? It'd be 10. So What we've shown here is that if the density of B is 5, the density of A is 10. So the density of A is bigger than the density of B, it's twice as big. And so what we need to put here is the density of solid A is 2 times the density of solid B. We can do the same for part B as well. Part B, we can just make up some more numbers. Speed equals distance divided by time. So again, let's pick some nice, easy numbers. Let's make them legal numbers. Let's pretend we drive safely. So I'm going to say here that, and again, you can make up whatever numbers you want, by the way. Maybe we travelled 60 miles and it took us 1 hour. If you did 60 miles in 1 hour, hopefully you'll see that means 60 miles per hour. It's not more than 70. We're just going along nice and steady on the motorway. But now it says if the distance is halved and the time is doubled, what happens to the average speed? Well, we said that the distance was 60, and so if we half 60, that would take the distance to 30. And if the time was doubled, well, double 1 hour would be 2 hours. And so how would that affect the speed? Well, the distance would now be 30 miles, and it'd take us 2 hours to do that. 30 divided by 2, half of 30 would be 15 miles per hour. And so the speed's gone down. So it's not been times by 2, it's not been times by 4. It definitely has changed. Has it been divided by 2? Well, 60 divided by 2 would be 30. So no, the actual thing to circle is it's been divided by 4. 60 divided by 4, a quarter of 60 would be 15. So the speed has been divided by 4. Question 23. A regular polygon has an exterior angle of 20 degrees. Work out the number of sides of a polygon. If you went around a full lap of a polygon, you would have turned around 360 degrees. And so 360 degrees will actually be the same as the exterior angle of a polygon times the number of sides. Because each time you go around a corner of a polygon, you'll turn through that exterior angle. After you've gone around all the sides of a polygon, you will have turned through all the corners. You will have run around all the corners and done 360 degrees. And so if you run around the exterior angle, the number of exterior angles you've got, the exterior angle times the number of sides, it'd be 360. So what we need to do now is to put numbers into this equation. So 360 equals the exterior angle, but we're told what the exterior angle is. The exterior angle for this one, we were told, was 20. And so 360 equals 20 times the number of sides. Let's just call it n. Your teacher may teach you many different ways of solving equations. I'm just going to be short and lazy here, but essentially you can think of it as that 20. You want n on its own, you don't want that 20 in the way. So swap the side of it, swap the sign. The 20 was multiplying n, opposite of multiplying is dividing. So n will be 360 divided by 20. If you don't like a division, treat it as a fraction and see if you can simplify it down first into nice, easier numbers. Well, both of these numbers end in a 0, so we can take the 0 off. Then we've just got 36 on one and 2 on the other. 36 divided by 2, half of 36, will be 18. So we've got 18 sides on that polygon. The next one, question 24. Again, this is where the questions do get quite hard. You're nearing the end of the paper, so the questions do get quite nasty. There's two main ways of tackling this one, so I'll show you both main ways that spring to my mind. So I'm just going to divide the page in half. So one way would be to get rid of these fractions in the ratio and multiply each number by the lowest common multiple. So the lowest common multiple of 2 and 3, the smallest number that's in the 2 times table and the 3 times table, would be 6. And so one thing we could do is times both numbers in this ratio by 6. So the first one, half times 6. Half times 6 is the same as half of 6, which is 3. And this one, 2/3 times 6, works in the same way as 2/3 of 6. 2/3 of 6 would be 4. Just to expand on that, if you don't like that explanation of it, you could do it like this, 2/3 times 6. Now, this is a fraction. This number isn't a fraction. You can make any whole number into a fraction by writing it all over 1. Then treat it as a fraction times a fraction. Top times top. Bottom times bottom. 3 times 1 is 3. And 12 divided by 3 would be 4. At any rate, the first number in this ratio, which was a half, we've now, by multiplying both sides by 6, we've changed that into 3. And the second number in the ratio, which was 2/3, by multiplying it by 6, we change that into 4. But the ratio we want is in the form where the second number is 1. So we've got 4 here. We don't want 4. We want to get the 4 down to a 1. So you need to ask yourself a question. What do you divide a number by to get 1? Well, any number divided by itself is 1. And so we need to do 4 divided by 4. But to keep the balance of the ratio, if you divide one side of the ratio by 4, you'd need to do exactly the same to the other side. And so on the left, we'd need to do 3 divided by 4. Now if you notice here, all the possible answers are fractions. So 3 divided by 4 we can leave in fraction form and just say it's 3 divided by 4. And so x dot dot 1 is 3/4 dot dot 1, and so x is 3/4, and so we need to circle 3/4. Another way we can do this would be to realise, this is a harder way in my opinion, but you can treat ratios very much like division. So a half dot dot 2/3, we can think of this as a half divided by 2/3. Even the dot dot of a ratio is the same as the dot dot of a division sign, so there is a link. A ratio is very similar to a division. Now with division of one fraction by another, what we need to do is we keep the first fraction, we change the sign, and we flip the last one on its head. So we keep half as a half, we change the divide sign to a multiply, opposite of divide is multiply, and we flip 2/3 on its head. So the 3 goes on the top and the 2 goes on the bottom. Now we just multiply the fraction as normal by doing the top number times the top and the bottom times the bottom. 1 multiplied by 3 is 3, and 2 times 2 is 4. So again, doing it this way, x would equal 3/4. Multiple choice questions. You've absolutely got to say something. Never leave a multiple choice question blank. Always, at the very least, guess. But I'm going to try and show you here how you can actually tackle this one logically. you've got information about 10 people completing a task. Now notice 10's a nice round number, so we could actually do calculations with this. And the first one is, say true or false of this statement. So could the mean be less than 20 minutes? So what we could do is we can work out the absolute minimum the mean could be. The mean is the absolute minimum when all the people in each category have waited the absolute bare minimum time. So the bare minimum for this category would be 0, for this interval would be 20, and for this one would be 40. Now you might be thinking, but t must be bigger than 0. You're right, and so this is more than the bare minimum. This is actually less than the bare minimum. So this is the ultimate lower limit we're going to work out. And so if one person did it in 0 minutes, as impossible as that would be 0 in total. If these 6 people did it in 20 minutes, 6 times 20 would be 120. And if these 3 people only took 40 minutes, then 3 times 40 again would be 120. So the grand total of times would be 0 plus 120 plus 120. Add up all these numbers and you would get 240. And so the bare minimum total time will be 240 minutes. But we're talking about the mean here. Now the mean is the total divided by how many values. So in this case, because we're talking about 10 people, we're going to divide by 10. Because remember, it has said it's 10 people. So we're going to divide by 10. 240 divided by 10 will be 24 minutes. And so if the mean could be less than 20 minutes, false. The absolute minimum the mean could be would be 24 minutes. That's a bare minimum. However, because we've worked this out now, we can actually answer the third question. Now the third question is saying the mean could be less than 40 minutes. Well, yes, it could. It could be as little as 24 in fact, so it could definitely be less than 40, but just not less than 20. And this one here, the mean could be more than 40 minutes. Well, let's just think about how big the mean could actually be. The mean is at its biggest when everyone in each category is taking the longest. And so if this person here in this category took 20 minutes, they would have taken a total time of 1 times 20, which is 20. The next one, 40 times 6, if 6 people took the longest possible they could, 6 times 40 would be 240. And the final category, if these final 3 people took the longest they could, they'd each take 60 minutes. 3 times 60 would be 180. And so the total of all these times would be 20 plus 240 plus 180. 0 plus 0 plus 0 is just 0. 2 plus 4 is 6. 6 plus 8 would be 14. So put the 4, carry 1 along. 1 plus 2 plus 1 would be 440. So that's a total maximum time it could have taken. So the total maximum mean will be 440 divided by 10, which should be 44 minutes as an absolute maximum. And so looking at the middle one here where it says the mean could be more than 40 minutes, we've just proven that would be true. The mean could be more than 40 minutes, it could be 44 minutes. So there. The next part of the question, we're talking about the range of times. Now range, in case you need to be reminded, is the highest take away the lowest. Highest take away lowest. So first of all, it's saying the range could be more than 40 minutes. True or false? The range is at its biggest when the highest is at its highest. So the maximum range would be the biggest possible value, which would be 60, and take away the smallest possible value. Now, although t couldn't be 0, t could maybe be 1, for example. So maybe 60 take away 0 if you wanted, or 60 take away 1 if you don't want to say it's actually 0. The range could be as big as 59. So yes, the range definitely could be more than 40. It could be 59 point something. It says here the range could be less than 40 minutes. So what would the absolute smallest range be? The smallest range would be when the highest is the smallest highest it could be. So the smallest possible value here in this category is 40. So the absolute smallest maximum would be 40. And the biggest minimum would be what's the biggest value this person in this group could have taken, which would be 20. So the smallest possible range would be 40 take away 20, which should be 20. So yeah, the range could be less than 40 minutes. It could be as little as 20. However unlikely that is, it could be as low as 20. And this final one, the range could be more than 60 minutes. Well, the range is the highest, take away the lowest, so as we said before, the biggest possible range we could have is 59 minutes and 59 seconds, all the way up to 60 as an absolute maximum upper limit. It can't be more than 60 because no one took longer than 60 minutes, and so that would be impossible. The range can't be more than 60 minutes because the biggest time wasn't more than 60 minutes itself. We're coming to the end of the paper now for the last 3 questions. So question 26, write 36 as a product of its prime factors. Give your answer in index form. This means write your answer down using power notation, so squareds and cubes, not just a list of numbers. So this is one of the ones where you do the factor trees. So on one side is what you divide in 36 by. It can be whatever you want to. On the other side, the answer to what that is. So if in doubt, if a number's even, I would just say to divide it by 2. So half of 36 would be 18. When you find a prime number, which includes 2, you circle it and leave it alone. 18, however, isn't prime because we can divide 18 by more than 1 in itself. Again, 18 is even, and so what I'd suggest we do is again divide it by 2. 18 divided by 2, half of 18, would be 9. Again, we get a 2, which is a prime number, so circle that too. 9, however, isn't prime because 9 we can divide by 3. 9 divided by 3 is 3, and now 3 is prime. When you've got primes at the end of each branch, then you stop. The final answer is all the numbers you've circled. So you've got 2 2s. Whoops. Just do that one again. Don't know what I was doing there. So we've got 2 2s and 3 3s. But because it says write the answer in index form, we want to write this in terms of powers. So 2 times 2 we can simplify as 2 squared, and 3 times 3 we can say is 3 squared. And so that's your final answer. It's 2 squared times 3 squared. 27. I won't get on to it now about my personal opinions, but yeah, these are the questions you're just going to have to sort of, in my opinion, last minute revision, 5 minutes, for a certain trigonometric values, which you'll need to know, and one of them is cos 90. I won't bore you for details, but the main thing you need to know is that cos 90 equals 0. For further explanation, I'd ask your teacher or do some further research, but it's one of those little itty-bitty bits of a syllabus which might come up, but here, multiple choice, if in doubt, have a stab at a guess, but there is a good reason why the cos of 90 is 0. I might well explain that either in class or a different video. Finally, question 28, simultaneous equations. The first step for simultaneous equations, you need to look at the letters and see if you've got the same number of letters, forgetting if they're positive or negative, in either equation. And luckily for us, we do in this case. We've got a y here and one y there. Now this y at the top is a positive y, the y at the bottom is a negative y. So we've got the same number of y's though. It's one y at the top, one y at the bottom, but different signs. So if the signs are different, what we're going to do is add the equations together. If the signs are different, we're going to add the equations. So we'll just add the 2x to this 1x. Both x's here, both groups of x's are positive, so 2x plus an extra x would be 3x. The reason we're adding both equations together is that we want one letter to vanish, and that will happen with the y's. Y plus a minus y. If you add a minus, it's the same as just taking it away. The positive y will exactly cancel with a negative y and leave us with no y's at all, which is what we want. So on the left hand side, we'll just be left with 3x's. On the right, 18 plus 6 is 24. If 3x is if 3x is 24 rather, we can work out what just 1x is by dividing by 3. So if we divide both sides by 3, 24 divided by 3 would be 8. And so we now know that x equals 8. We could have also done the whole swap sign thing if you wanted. That 3 is multiplying the x. If we swap it to the other side, swap the sign to the opposite of what it already is. Opposite of multiply is divide. So knowing that x is 8, what we now do is we need to put x equals 8 into one of the initial equations. The top or bottom, it doesn't matter. But let's say we put this into the bottom equation. Put this into the bottom equation. Now the bottom equation is one that says x minus y equals 6. So I'm just going to write that out exactly as it is. X minus y equals 6. But we've just worked out what x is. We've just found that x equals 8. And so we can substitute this value for x. So we're going to take away the letter x and put in its place what the value of x is. X is 8. And so we're going to put in the value 8. 8 take away y, whatever y is, equals 6. So what number, when you take it away from 8, would give you 6? Well, 8 take away 1, that would be 7. But what's 8 take away 2? 8 take away 2 would be 6, and so y would be 2. And so your full answer is that x equals 8 and y equals 2. So now we've done the whole of the paper. So have a look back at the questions you got wrong, see if watching this video helps. If not, you can ask your teacher in class and they'll try and find a different way of explaining to you and maybe give you some help or additional resources on those areas you're struggling with. So thank you for watching, and I'll see you again soon.